But yeah, I'm going to tell you 3 seconds before we go live. I hope that's not a surprise. I'm not sure if it mentions it in the notes because it was a while since we did that. But maybe. Okay, I'm going to do an introduction and we'll get started. Welcome everyone, by the way, the live watchers and listeners. Hello. Here we go.
Let's do it. It's go time.
Hello and welcome to Go Time. I'm Matt Ryer, and today we're talking about instrumentation and instrumenting your Go code specifically. I'm joined today by Johnny Boursiquot. Hello, Johnny.
Hello there.
How's it going? It's been a while.
Yeah, it's been a while. Yeah, we haven't been on a show together for a minute.
Yeah. No, I know. Yeah. Yeah, not for a while. Well, you don't just have to tolerate me on your own, Johnny. Don't worry. We have some guests today to dig into this subject. We've got Björn Rabenstein. He's here. He's an engineer at Grafana Labs and longtime Prometheus contributor. Hello, Björn. Welcome to Go Time.
Hello. I'm glad that I'm finally in this podcast, of which I'm a great fan.
Oh, well, we're great fans of yours as well. And we're also great fans of Bartek Plotka, who's also joining us. Hello, Bartek.
Hello. Nice to be
Bartek is an engineer at Red Hat, a maintainer of many open source projects in Go. You've probably seen his name around GitHub here and there. Maintainer of Prometheus and Thanos, and you're authoring Efficient Go. Is that right, Bartek?
That's correct. Hopefully published this year.
Yeah, that's exciting. How is it writing a book? Is it what you thought it was going to be?
Definitely not. Definitely not. Lots of pros and cons. Lots of learnings.
Mm-hmm.
I think it's worth it, but maybe once a lifetime.
Just one book will do. Yeah, that's how you feel now. Maybe you'll get the buzz. You get you get the bug for it. Well, we'll see. Okay, so maybe we could just start at the beginning. For people not familiar, what is instrumentation? What's it useful for? Bartek, maybe you could kick us off.
Right. So how I see the instrumentation is essentially it's about generating the signals that will tell us later on how your application is behaving when you don't have visible access to how it's running. So maybe you are putting that on production in your cloud. So maybe on your friend's machine, you're just spinning up the process out of your Golang code that you created, and you have to have some kind of those magic words, monitoring or observability. So ability to really derive the state of this application only from its observability or monitoring signals. So in order to generate those signals, we need instrumentations. So essentially, we need instruments that tells us what is happening remotely. This is as simple as that. Now, of course, this can go even more complex because you can have either manual instrumentation, so you are directly adding a code statement to your Go application to add a log line, to add a metric, to create a span, tracing span, or maybe there is a Golang runtime logic that creates profiling, right? And probably we can discuss this, all of this in this episode. But there are also automatic instrumentation mechanisms where you can deduce the application state essentially from, let's say, closed box pattern, where you can essentially ask operating system. So essentially kernel, this is what is very popular nowadays with this eBPF solutions that allows you to really understand what process is doing without any manual statement, right? So essentially this is the categorization, like manual instrumentation, automatic, all to derive some signals.
Great. And so what's this useful for then? So we find out that like we can find out things going on inside. So what's like a specific example of something that you might want to instrument and then report on?
So feel free, Björn, to chime in. But there are plenty of things. And I think first and the foremost is something that we can read in popular SRE book, right? So essentially, Google team who kind of created this SRE movement, site reliability engineering. We can read there that monitoring is like a key component in building any application, in the cloud. And the reason for it is that you don't know if it's running if you don't, observe some signals. So health monitoring is kind of the first thing you do. You want to ensure that it's actually doing any work. If you are not looking on it, if you are not actively poking, using its I don't know, HTTP requests or looking into its work items. So health is the first thing you want to check out probably.
And so that's like a real endpoint running on the server that just returns like some okay. And so if you can reach that, then the server's at least up.
That's the basic, that's the basic solution. That is not, the best, because if you're not looking, then it might be down in those, periods when you are not poking it for 200 requests, right?
Yeah.
So there are many, many different methods of how you can possess this information about healthiness.
I mean, the what we got with the age of cloud or the age of distributed systems was also a notion of that just being up or down it's not that easy anymore, right? Your servers consist of many microservices, and every microservice has many instances. Some of them are always down because once you have enough of them, they will never all be up. So you get into this whole area of, we have to tolerate a bit of downness. And then you start to think that just probing for up or down for this like binary result isn't enough anymore. This is where you start to want perhaps some metrics about your running tasks. And that's where the instrumentation also, I think, gets into the game, right? If you just run a probe to see if something up, you arguably don't really need instrumentation. You just check out if your endpoint is up, right? And I mean, this is what I call the founding myth of Prometheus. I have to talk about Prometheus, of course. I mean, I don't know if it's literally true. I was joining the Prometheus team very early in its history, but not from the beginning, right? So I also got this just from stories. So this is why it's all myth in the distant past. But I mean, sometimes you get nice stories from that, right? And the mythological version is that the first idea for Prometheus was actually, we need to instrument our code for metrics. And then the initial founder started to create an instrumentation library. And I like to believe it was the Go library they created first. It might have been the Java library, but let's assume it was the Go library because it's a Go podcast. And that might even be true.
Would you assume that it was the Java one on Java time?
I don't know. I think I will never be on Java time if there's anything like that.
Okay.
We'll see. 10 years ago, but what?
Yeah.
So this was the initial spark of inspirations. There was an instrumentation library where you could instrument for metrics, and you would expose a separate endpoint. I think Bartek mentioned that shortly, that you have a separate endpoint where you not just collect, is it up, but you can collect the data from the inside of your running binary. And then the next question was, okay, how do we scrape this data, and where do we collect it? How do we store it? How do we read it? How do we query it? And this is where then the Prometheus server got invented, essentially. But it all started with instrumentation, and maybe with the Go library, which still exists. And Bartek is the current maintainer of it, and I'm the past maintainer of it. It's one of the most used Go packages in the universe, I think.
Wow, in the universe. Wow. I mean, that's assuming Go only exists on this planet. We can't say for sure.
Or just in this universe, because there is a multiverse. From
good point. Well, but still not bad though if you're the best Go package in this particular universe, even if there's more stars in other universes.
Is there Go on Mars? There must be Go on Mars, right?
Yeah, there must be by now. Yeah. That's a great.
And then there might be client Golang, Prometheus client Golang might be on Mars as well. Who knows? It's
really?
running in all the German, like on the rail stations. They use it to monitor those.
Did they?
So it's running everywhere around me. It's pretty cool.
Oh, if only you'd instrumented it and was reporting that somewhere, so you could see where all the places it was running. That'd be awesome. Actually, I would like that as a feature, please, because for all packages we ought to have that so we can see how it's being used. But that's
I mean, the popularity of this library is actually, for me, it was a huge surprise. And that's also, I think, an important topic about instrumentation. That back then, like we're talking about the year 2012, it was very uncommon for normal developers to even think about instrumentation. I mean,
Yeah.
if they really thought about it, they would realize even putting a printf statement for debugging into their code, or a log line, emitting a log line, that's already instrumentation. Instrumenting code for like profiling is instrumentation. Luckily, we get this for free in Go. So they kind of did instrumentation, but they would never think about instrumentation for monitoring. This was completely an ops concern, right? And developers would never think about ops concerns. And like teaching them that they have to instrument their code for things like monitoring was a big deal, right? I didn't expect that would get traction so quickly. But of course, DevOps movement, blah, 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 all those things. So that might have helped. Also, developers might have pretty quickly realized that if you instrument your code for even more things like metrics or tracing or profiles, that it even helps during development. That's also an important thing, that monitoring per se is like everywhere in the stack, right? It's not just in the end when you add it as an afterthought and you need it to run your system.
Different people have different needs, right? So when we talk about sort of the operational, sort of if your organization is large enough to have a dedicated ops team, where the people who care about the VMs, right, and basically making sure that CPU is not spiking, or there's enough memory, or whatever it is, like managing sort of that, if you will, the lower level set of concerns, sort of at the infrastructure operational level, and then you as you sort of go up the stack, if you will, then you have a different set of concerns, right? You have the developers that are instrumenting, maybe to find out, okay, how if let's say you wanted to sort of send traces out, right? You want to know, okay, what in this long running process, I'm gonna have a subspan, right, to tell me how long this particular part of the whole thing is taking, and things like that. So that gives you that sort of that debuggability, right, that understanding of what your system is doing on any given sort of request kind of thing. But then I think there's an even higher level to that, where the you instrument things and you can tell, right, the whoever asked that, okay, the service is up, right? I can hit on the health endpoint or readiness endpoint. Hopefully it's not just a ping to get a TCP response back. Maybe it's something you do, something meaningful that says, okay, the system is operational, it's actually ready to process requests successfully, kind of thing. But beyond that, right, you're gonna have the can you answer, is this thing doing what the business wants out of it, right? So you're not just saying, is this thing up, right? If your thing is up, but it's maybe you're failing process 1 out of every 100 credit card transactions, and you can't explain why, right? At scale, that's millions of dollars potentially, right? So there are some things that the business is going to care about, right, that instrumentation can help you answer, right? But you have these different layers, right, of observability, right? And different parties are going to be interested in different things, right, depending on who you ask. I still have people who use Nagios as a tool for instrumentation. Well, I'm not going to throw my developers into a Nagios dashboard and say, hey, go answer me some questions about, the business KPIs or something, right? But yeah, I'm going to use, kind of different tools. But I think the observability really, I think it's an all-encompassing term now, which I think has gotten sort of diluted a little bit ever since we transitioned from calling things monitoring, right, to now using sort of the more trendy term observability, right? And I think that's going to mean different things to different people. But like instrumentation sort of remains, I think, at the end of the day, whether it's automatic or sort of manual, that sort of remains for the developer specifically. That sort of remains that the ultimate source of truth beyond logging, right?
Yeah, and I would like to kind of add something to your points, both Björn and Johnny, about instrumentation. I think it's very underestimated, how much work it takes to really build a solid instrumentation library. because like the amount of work you put, Björn, in this client Golang that you were surprised is popular. Well, it's because it's so hard to produce one. And, especially when I joined kind of maintainership of this package or like module, really, it is so much work in terms of, making sure the code is efficient, because suddenly so many, applications are just, importing this package. So modules. So suddenly, the amount of dependencies really matters. The amount of, the efficiency of the code matters. The API, scope script of this really, really matters. And I was just today trying to, well, what we did, let's be honest, we made a little bit of mistake on the newest client Golang. So Go team member really helped us to implement, essentially move to different runtime metrics for Golang processor. So, in client Golang, you are able to essentially expose really interesting information about your Golang process and around, garbage collection routine and, memory and essentially heap allocations, like how many tiny objects and big objects you are kind of allocating, like very low level kind of information. So we kind of consume that. We merge this contribution without clearly looking on maybe like how many metrics you are exposing, and we suddenly expose maybe twice more metrics, and suddenly we are impacting many Golang services, because suddenly they are kind of scraping twice more metrics. So the kind of amount of thoughts that have to go through those instrumentation libraries is enormous. It's not only metrics, and it's even worse when you're talking about logging instrumentation and trace instrumentation, because it's just even more data that you are passing through, and you don't want to your application, you want to pay for this application compute power for doing a normal work and not monitoring, right? And sometimes if you implement it wrongly, if you use those libraries wrongly, if you make maybe wrong decisions, you can pay much more for your observability than for your real application. So that's a risk here, right?
So it really matters, doesn't it? It's amazing actually to think of that. Like, I genuinely probably naively thought that library was quite simple, that it was just had some helpers that would collect buffering maybe, and then sending off batches or making them available or something. But yeah, now when you mention like often I will tell people, don't worry too much about optimizing yet. Like, get something built that works first, and you can optimize it later when it becomes a problem, if it ever does. This is one of those times where it really matters that this isn't an expensive thing, because people are calling these methods all the time, aren't they? They use that client everywhere. It's almost in every code path.
Yeah. You definitely don't want to think, you don't want to consider if you use that or not. You just want to use it, and it doesn't have a significant penalty. Like similar to like when I realize in a Go binary, like profiling is kind of always on, and you just have this endpoint if you just like anonymously import this package and stuff like that. It was like, weird, isn't that expensive? Should I switch that off in my real production binary? But no, it's like it's all designed to be like, I don't know, a fraction of a % of your total resource usage. So you just leave it on, you don't ask questions, and when you actually get in trouble, it's there, and it doesn't matter if it's like developer trouble or ops trouble, it's just there, and that's so cool and so good to have.
Yeah.
Right, but there are configuration variables for those Golang profiling that increases the frequency of increasing the sampling or frequency of CPU profiling that can trash your application completely, or you can actually reduce it. So there's lots of things you can control here.
And does that just sorry?
And in the what you just described, Bartek, right, with those new Go runtime metrics, now we also need to consider if we make this user configurable, because it's so many metrics that if you don't need them, it might be too expensive, right? So of course, there are trade-offs, but the ideal state in like some utopia is you just have everything on and it costs you nothing. And we try to get as close as possible to that.
Bartek, you mentioned earlier that you made a mistake in the client. What was that specifically?
You like, let's talk about mistakes. Yes.
If you don't mind.
No, of course.
That makes me feel better.
Yeah. Great, that's good. Yeah, so I think that the mistake is really around, we didn't have time, to review exactly properly everything, and the change was pretty big. And as maintainers of client library, I think we just kind of get that from Björn hands, so we're kind of pretty new. And essentially, the usually it's really about memory runtime metrics that Golang allows you to achieve. So usually, what you could do, you could create this runtime.memstats structure, and you can just program runtime.read memstats and provide the structure, and that will fill you the structure with statistics. And this is how we used to kind of get those metrics and give you kind of very easy one-line statement that you provide in the beginning of your application that continuously expose this information, very, up to date. So Prometheus can scrape it and have, up to date heap information, how many allocations you did on the heap, what's your GC latency, and so on. Now, what happened in the Go, I think 1.17, was that runtime/metrics package was introduced that kind of give even more information about internal Go runtime. And we wanted to switch essentially to this new format, right? So totally like go away from this memstats logic. However, what's happening with especially metrics is that we all care about cardinality. We want to make sure the metric is stable, because this is what allows us to aggregate over time and over different series and kind of compare to each other. Like, this is kind of the key concept behind metrics. And also the cost of metric system really depends on uniqueness of those series, right? So yeah, we just introduce a new unique series, so a new names, and this is kind of what we could avoid. What we are trying to kind of fix right now is to add essentially some optionality, right? Some configuration pieces. So especially because this library is so used, so popular, we need to make sure it by default doesn't increase your metric count twice. So this is generally kind of what we try to achieve. So we have a kind of community who wants to have this new runtime amazing, granular metrics. So we kind of approve it and merge it, and then suddenly the rest of the world was like, oh, why I need to pay twice more? I don't understand really. So this is the really the trade-offs we have to make in for such popular module. It's kind of much more stressful and kind of much more work than if you could just break API on every release. Right?
Yeah, that is like a big responsibility, and because it not only because it took off and became popular, but also the nature of it, the fact that it's found its way everywhere. I mean, it really is probably everywhere now. So it really does matter the decisions you take. How do you balance that? Like, is it a tough balance? Do you argue? Is there a disagreement about what can get in and not? Are there some people that are really paying attention to that cost and things?
Definitely, yeah. Like, after merging this feature, we got like 20 or 12, let's say, issues. So and like very friendly ones. So we were very, very, I mean, it was amazing community contributions to just report some problems. So I think that's the pros and cons of like such popular module, as that you get early feedback, but also you have to kind of make sure you are not making mistakes a lot. But generally speaking, I think there are basic rules when you're writing any Golang code, especially that is consumed by others, like library modules and packages, that saves your life. For example, any new feature you should add under new API, under new methods. You don't change, the existing code. We are, whenever we want to change something, we are, having this, in comments / deprecated kind of, special word that is actually handled by the IDEs like Golang and others that automatically, points you that this code is, well, it's for compatibility reasons there, but there is better solution somewhere else. So there are certain rules that you can go with. But of course, at some point you need to consider V2 or V3 or V100, and that's a big chunk of work, unfortunately, nowadays with Go.
Yeah. I like that you got nice issues though, at least. Like someone's like, thank you so much. I love the recent PR, but
I need to pay millions.
My kid didn't need to go to college anyway. Probably smart enough, didn't need it. Yeah, but that's nice that they're nice. Be nice on GitHub, everybody. That's the lesson there.
Yeah, and this is why I solved the switches, because you were nice to me. Yeah, exactly.
There you go. Yeah.
So
even for features that are really like non-controversial, it's if a package is used so frequently, you are really, really, really concerned about not breaking anyone, and that sometimes is weird, right? Also, like when we added exemplars is also a huge thing, right? In recently, perhaps we can talk about that later, but like for now, it's just a new feature that we didn't think about before. And now we had to add new methods to an interface and stuff like that, but we didn't want to break anyone. So now you need interface upgrades, like little Go tricks. They look weird if you just look at them like in isolation. But if you realize, okay, I couldn't break the users of the old interface, then it perhaps makes sense. But you get this kind of cruft in the library. And yeah, I mean, I think we have been talking about a legendary V2 for many years. It's never happened, but they're also like you conserve weird coding patterns back then in 2012, 2013. Guess what we all thought? Channels are the coolest thing, right? So we put channels in the function signatures, essentially used them as like concurrency safe iterators, which no, that's not what they're supposed to be used for. But they're still there, because if you now just change and tell you, listen, here's this much cleaner signature for the function, now please, all the code in the world, please change to that new function. It's pretty hard. So we still have those channels there, and if you think that's weird, yes, I agree.
Yeah, the cruft you mentioned is interesting because we in Go especially, we pay a lot of attention to writing very easy to read, maintainable code, and sometimes we'll sacrifice performance in the right place, for readability. And then whenever you have to then optimize, of course, you're doing different things, right? You're doing more complicated things, or you're finding little ways to save memory or avoid allocations, those kinds of tricks. And then you end up with sort of mess and unusual bits and things you wouldn't be very proud of, maybe. But really, like, that's just the reality kind of how it evolves. And I think the stability in the API is worth it. And I'm sure the community thanks you for the attention paid at that level, because if this was a package that was just breaking all the time and you never knew what you could, you'd end up with all kinds of horrible things when like a dependency used a different version and things like this. So I think I can speak for everybody when I say thanks for that.
Yeah, lots of trade-offs there are, and I think what's also cool about this is it's just one module. These days, it's so popular to create like instrumentation libraries with like 10 modules because you want to be, I don't know, generic or have different versioning across. It's really hard to consume. But I have actually a question, Björn, to you. So you kind of started this library, I presume. Have you been, designing the APIs with optimization in mind, and you did benchmarking, or you rather created APIs so it functionally works, and only then maybe after a couple of years you were maybe optimizing implementation?
I mean, I didn't start it, right? I took over from the founders of the Prometheus project, like Matt and Julius. They started this, and when I joined the team in 2013, I think, then I was like, one of the tasks I took over was this instrumentation library. And even back then, like, it started essentially with the whole rewrite, but I tried to keep like the spirit intact. And yeah, we thought a lot about optimization because we knew like this is in like every path if you instrument your code. But often we were wrong, right? And micro benchmarks is a cool tool. My first GopherCon talk, that was at the second GopherCon ever or third, I don't know. Like back then, I was really exciting. It went quite well. This was essentially about how to increment a float in a concurrency safe way, and still so that it doesn't kill your performance. And it's a little lecture. I mean, this is perhaps why this talk went well, because back then we were all learning, and it was a little lecture how like micro benchmarks can help you and also cover those things. But yeah, it's of course like all the stories about premature optimizations and everything. It's interesting how also later you realize when your programs get faster and they want to increment this counter really often, how that is problematic. Then you have histograms where you want to increment buckets. And then you realize they have to be incremented all together, because otherwise you can get inconsistent results if you collect your data at the wrong time. And then this created a whole talk from mine at GopherCon UK about like all this concurrent programming, how you can do a log-free atomic increment of all those buckets in the histogram. And yeah, it's kind of, even from an academic point of view, it's interesting, but it all comes with this warning: just don't please do this for fun, but not in your production code. But if you do it in your production code, it should be really well justified. Is this really in a path where all this complexity is worth it, and all the risk you take by doing this in the weird way? Like, if you like, you can just go into the histogram code in Prometheus client Golang. It's really weird, but it's also fun. Yeah.
So speaking I like to sort of put myself in the shoes of a user, right, of these instrumentation libraries, and necessarily a maintainer of them, as we've sort of been, that's sort of the lens we've been using for a little bit. So if I wanted to sort of instrument my code, so we've already sort of teased out, right, what instrumentation means to different tiers, right, within sort of all the people who are concerned about sort of the observability, right? So if I wanted to, if I'm new to observability, right, and I'm looking to sort of figure out, okay, what does it even mean to instrument my code? Like, what is it that I should be looking at, right? How do I figure out whether I should be measuring requests per second versus latency? Like how do I even approach this world, right? And obviously there are the different libraries that do different things. There's Prometheus, I have to figure out where that fits in my stack. There's open telemetry, and then there's metrics, and there's this and there's that. Like, it's traces. Like, how do I, as a developer, when do I use what tool and for what?
I mean, I think there is a problem that who knows, if you use Prometheus for metrics collection, perhaps you use something else, and then you want to instrument not just for metrics, but for all the other things. And of course, you have a lot of choices to make, and then there are a lot of efforts to unify this. Like, OpenTelemetry is definitely a huge effort of like tying up all the loose ends, and it's really hard, right? So the first question in a practical context is, you should look at what your organization you're working in is doing. And often they use some framework, right? They use whatever. Let's start with a web router. You have your favorite Go web router or whatever. And then from there on, you can kind of inform that decision. At SoundCloud, we had the most microservices at SoundCloud are running on the JVM, and they had this is also like somewhere in the public, people talk about it. They had a kit for that, right? I think it was called JVM Kit, where they had all the framework how to write a microservice at SoundCloud, and then they put instrumentation in there. So just merely by using this framework, which you would use anyway, you were instrumented for traces, for metrics. You got some logging, some standardized logging. It's all in there. When we phrased this, we phrased this coin. Yeah, no, we coined the phrase that at SoundCloud, it was easier to get monitoring than to not get monitoring. You couldn't avoid it, right? and that's, for many developers, you're already in some framework, maybe literally like a software framework or the framework of your organization. And there might be something, or if there's nothing, you might just put the pieces in there and you could look for the right thing. I mean, rarely you have like a greenfield approach. If you do, I mean, that's also fun, of course. You start your first Go program, And then you could just link in the Prometheus client Golang. It's like there are very minimalist programs in the documentation where you can just link it in, expose an HTTP endpoint, and do nothing else, and you already get metrics for all the Go runtime stuff, for some process metrics. That's like more like an OS level stuff. And so you don't have to do anything to already get ton of useful metrics out of your program. And then you can go on. You can like do really low level metrics instrumentation. I also have a talk about this somewhere in my portfolio. We might link this, but there's also a set of middlewares. I don't know, perhaps Bartek, you can talk about the middlewares we have, because that's also very nice. How Go does HTTP thing, it plays very well with that.
Yeah, it's worth to mention, because you need to re-implement every possible metric instrumentation. So for example, if your application is doing HTTP requests, which probably 90% of applications do, you don't need to create a special separate HTTP request metric or actually logline and trace as well. There are libraries that abstract this for you and say you are having a standard HTTP. You are using standard HTTP library to create a server. You can just put a middleware, which is essentially a wrapper over your HTTP handlers, that will instrument automatically with very consistent metric that are already someone thought through those to make sense, to make something reasonable. And actually, the other plus of it is that you are getting a lot of observability for free. So someone probably already built some Grafana dashboards and maybe alerts and maybe recording rules for this information, right? So I think Björn, you created an HTTP Prom HTTP package in Prometheus client Golang, which already does that. And I'm maintaining gRPC library because we are using gRPC a lot. It's very popular protocol, and we have literally the same middleware. They are called interceptors, but essentially they are like wrappers over gRPC things that adds metrics, but also we add logging and tracing in this module we could link.
Well, that brings us to a new segment that I've just literally made up, but the editors do a great job when I do this. It's time for Explain It Quickly. So I'm going to challenge you, Bartek, to explain exemplars as quick as you can. Exemplars, we mentioned them earlier. What are they?
Okay, quickest.
Go.
I think the easiest way to mention this, it is essentially an information that allows you to show an example situation that triggered some metric increment or metric latency observation, size observation, whatever you are measuring. So, and you can essentially, usually it's just a string, some characters and some timestamp and actually exact value of this example situation. So usually we put there a trace ID to correlate with other signals like tracing, but we can put request ID, for example, to correlate with logging. You can put anything, but it's pretty useful for recognizing an example situation that is represented by this metric increase, decrease observation.
Oh, congratulations. That's very, very well explained and pretty quick as well, which, really gets into the spirit of things. So thank you for that. Okay, so but you don't include an example in every case, right? Do you do this kind of randomly? How do you decide when to omit an exemplar?
Björn, go for it. I can see you want to speak that.
Do I? I mean, I'm not even sure if I'm the most qualified person for that. But anyway, I mean, the thing about if you use metrics to measure something that is essentially just a whole bunch of events, like your HTTP request, then metrics means you count them all together, you kind of aggregate along certain dimensions, and then you have this like gigantic number of requests, but you can't save them all. So this is where example is coming from. Like, it's just an example. So you pick one, and then of course, which one do you pick? Do you pick a one that represents a normal request, or do you pick one that's like an exceptional one? Probably you should do one of each or something, but not too many of the regular ones because they are boring. You just want them for reference. Like that's actually a super interesting question, and we have a similar thing when you do like logging or tracing, where you do try to collect every single event, and you realize you can't really do this. So the naive thing is, I just sample every thousandth. Complicated word. Or then you realize, no, that's just getting me the regular ones, but I want those rare ones that have like a long latency or they failed for some reason. So it's a super interesting decision, and I think this is a hot topic of research right now, right? Which exemplars do I actually want to have? The current, like if you have a normal Prometheus histogram and put exemplars there, they just put the last observation that fell into each buckets, which is, I think it's a pretty good heuristics, because you get exactly like one exemplar for every latency band you're interested in, which is a good start, I think. But I think this can be improved upon, and it will be interesting what the future brings here.
And I think it's important to mention that exactly what you did say about sampling. Like we have to make sure the example you put there, so example trace ID, it is the one that will be sampled and provided in your tracing backend, right? So those system has to be at some point connected. And I made some demo, like it is very possible with client Golang to just, talk to your tracing library to tell what trace ID you can put as long as, it's sampled. But of course, there is a problem if you have tail sampling and other complex scenarios. So it's definitely not solved problem.
Yeah, we had those discussions a lot. Like the tracing system should just sample those that Prometheus has at exemplars. That's the one direction. Or the other is you somehow want to tell your binary to pick the exemplars according to what your tracing system has sampled. So it's a bit of, hen and egg problem.
Anyway, if you are using client Golang and you are using tracing and you are not using exemplars, you are missing out. Like it's very underestimated feature. Please use it.
There you go.
When should you adjust your sampling? Like in the beginning, are you just basically saying, okay, I don't want any sampling, I want everything, right? Because I don't understand the system yet. I want to detect patterns or something like that. And then maybe before production, you pick something that makes sense for given the amount of volume and cost, right? Because the more data you collect, the more expensive it gets. So what decisions are you making about sampling and at what point in time?
Oh, Bartik, you should be in a better position to answer this.
Sure. So it's really tough situation because it's really around tracing, instrumentation, and libraries. Usually sampling is not application driven. It's really communicated or like done on collector level or agents, and so there are different phases you can do that. So it has to be collaboration between every every of those signals. What works for us is that like literally we use that on our production system is you have whatever sampling it suits you, as long it's not tail sampling. So then it's very easy to essentially provide a proper exemplar to the proper metric. As long as it's tail, this is kind of impossible.
Can you define tail sampling?
Yeah, of course. So tail sampling is when you decide that you
can do this slowly, Bartek. This isn't part of the segment. Do it fast. You can just take your time on this one.
Thank you.
Yeah.
So tail sampling is when you decide if you are throwing a trace span or you are saving it in your backend system after the event the request happened, because as we know, traces are really bound to some request. And it's very useful because you can often have a heuristic that will decide if you sample or not based on the result of this request. If it was slow or if it's failure, then probably it's interesting to sample that. If it's just a success, it's boring. Like who wants to check successes, right? So heuristic along those lines are tail sampling.
Yeah, so this actually, the more I learn and hear about this, the more complicated it seems. Is it possible like that Well, should everyone pay attention to this like now? What point in a career like should a young engineer really start paying attention to this? Because, like you said, Bjorn, we didn't really do it at all. It was kind of handled usually by somebody else in some other way. And Johnny, you mentioned that you use monitoring to find out if the system is doing what the business needs it to do. So it's pretty important, isn't it? Should this be a fundamental piece that everyone gets to grips with in some small way at least?
I mean, I wrote this little piece in this 97 things, every SRE should know about the third age of SRE. And it kind of ends with that sentence where we are like really in the third age of SRE. If SRE is like taught at universities, you just, as if you're a computer scientist student in your, like, even before you get your bachelor, you should have a few courses about, let's call it SRE. I mean, I don't know, words are hard, right? And those things would definitely include that you need to instrument everything, and it's just essential. If you are like looking for your first job, you might even check out if that company you're working for is already doing this. Because, yeah, if you don't, I mean, if you're experienced with that already, you could even evangelize this in an organization. And it's great fun because it's so satisfying to see all the progress you made by just introducing this, right? I mean, that was when back at SoundCloud, when nobody knew if the site is even up. And then even the like simplest things you do, they are so much relief. So that can also be quite good. But if you want to learn something in your first job and you want a role model organization to work for, that might be a good topic to look at if they are doing proper monitoring.
Oh, a good question for the interview there, maybe. Johnny, aren't you an SRE? Aren't you literally an SRE right now?
Yeah. And I just realized where I've come across Bjorn before. We're both co-authors in the same book, 97 Things Every SRE Should Know.
That's how you met.
That is
okay.
Yeah. That is kind of, yeah.
That's a nice way to
amazing.
meet.
I
Well,
know, right?
the other 95 you should all get together with the other 95 and have a big party.
The
Yeah.
weird thing is there are actually 98 things in the book, and mine
Right,
is the
right.
98th, so perhaps I don't really belong.
Is one of them a section on how off by one errors?
Yeah.
Yeah.
Actually, there are, and the funny thing is, it's not one per author. It's like there's fewer than 97.
Oh, that'll
or
save you
98
effort.
Yeah,
That'll
some
save
of us
you
wrote like 2 or
flights.
3.
Okay.
Yeah, that's fine.
Oh, it sounds good. Well, I recommend people get that book. By the way, I've read it, and yeah, I do genuinely do recommend it. Guess what? It's that time. You won't believe it. It's time for Unpopular Opinions.
Mm.
Oh, it would have been so good if the music worked.
Mm-hmm.
Okay, let me try it again. It's time for Unpopular Opinions. Oh, it sometimes just doesn't work. Right, we'll just have to all sing it.
You start.
Oh no.
Oh, that's so annoying. Well, it'll be in the real version, It's just
Yeah.
this sometimes crashes. Tempted
is
to restart.
My most favorite part of the show is that exact jingle.
Yeah, I know you don't get it.
I so love the spoken words you have in the background.
Can you hear that? No.
No.
Okay.
The
It's
live
just playing it
Twitch.
for me now.
It will be in the
Yeah,
final. It's
if
just
it's
playing in your
live
head, Matt.
Twitch.
Yeah. Yeah, that's all I hear now.
You should be humming it or singing it or something.
I know, but hang on. Oh, I can't believe it. Yeah, it works for me, but it's not working on here. If I had more confidence, I'd just get my guitar and just do a live version, but there we go. Who has an unpopular opinion for us?
I have a very pressing unpopular opinion. And it's because we already used that word that I don't like, and I hope I didn't use it. That's the O word, which is the word observability, right? I mean, my unpopular opinion is that I think this word, if it ever had a reason to be used in our profession here, it has lost all meaning by now. I can very well understand why people came up with this word, because I mean, I already talked about like this paradigm shift that people sensed when this where developers thought monitoring is just an ops concern, and ops people were monitoring by just probing the HTTP ports or something, or pinging the server or something like that, and staring at dashboards. And when people realized this is not enough, and then you started to realize there's so much more you need it for other things, like just keeping your site up. We didn't even talk about things like capacity planning. I mean, we talked about business a bit, right? And then all those like different signals you have. So I totally understand that some people felt this urge, we need a new word for that, right? But then I don't know, like observability, arguably it's coming from control theory, and I think control theory is super relevant for monitoring, right? But it's a rather specific theory, and like just taking a single technical term from a theory and telling everyone this is now the new word. I don't know. Like it's I'm more a fan of, instead of overgeneralizing a very specific term, just take the existing terms and appreciate and acknowledge that we have all very different ideas what that term actually means, and try to find like a wider, more common understanding of that term, right? Now, of course, the problem was also that then people used this word observability to essentially say, so you are just doing monitoring, but I'm doing observability, or my product, my software project is an observability project, and yours is just a monitoring project. And then it became a bit of like a word to fight over. What that means is then the marketing people will pick it up, right? And then someone came up with the legendary 3 pillars of observability, which sounds so great. And I mean, it was, as a concept, it really conveyed some insight and some widening of ideas. But of course, everyone picked it up. The marketing people picked it up. And then it was used so much that it became like, then people had to discuss why 3 pillars of observability isn't enough. So you run in circles. You have the same thing. And I don't know, like, of course, I was brought up at Google essentially, where they just called in monitoring, and they had tracing before people knew what it was, and all those things, right? And we just called it monitoring, and it just worked fine, right? So for me, it's like observability is like, if you want to use the term, it's something like a property of your system you want to have, but for me, it's a subset of monitoring. Well, most people think like monitoring is something that might be part of observability or not even. I don't know, like what's his name? I blank out. I always blank out on names.
No worries, but I just realized, Björn, that I was always saying that monitoring is subset of observability, and now we are saying it's opposite, I guess.
I see it like, I see, yeah. Corey Quinn said, he always says on this podcast, observability is the hipster word for monitoring. And I kind of like that, but I would say observability is the marketing word for monitoring, right? And if engineers call something a marketing word, it's probably doesn't mean anything good in a way, right? So I think if I use the word, it might mean exactly what I want, or it might mean nothing. And yeah, I just stopped using the word. I just use monitoring. And if you ever hear me use the word monitoring, I use it in the widest sense. It's not just Nagios probes, and it's not just metrics. It's everything, right?
Do you use the word serverless?
I do use the word serverless, but it there's
yeah.
Bartek and I just discussed yesterday, or was it today? Yeah, no, it was today. Like, it's a long day. We discussed how there are serverless applications that are not really serverless, and then there are the true serverless applications that nobody really caters for because it's so rare that you have this pure use case. But yeah, I mean, words are fluid, right? We have to embrace that. But it doesn't become better if you add more words to the mix and then very aggressively push them.
Well, we'll be tweeting out that opinion to find out once and for all if that is indeed unpopular or not. Bartek,
Oh yeah.
have you got an
Do we have a
opinion?
time for my unpopular opinions?
We do. It depends. How long
Depends,
is it?
yeah. Let's see.
Yeah.
All right,
measure
so
it.
quickly. So I was thinking a lot, like I have many unpopular opinions, but some of it that I would truly want to, I don't know, inspire others is that, and stay with me on this. It might sound childish and unprofessional for the start, but I think Go language is the best foundation and platform to program every software in the world. And I'm living in it, from embedded system, robots, browsers, mobile devices, I don't know, machine learning, configuration, even like infrastructure as a code. And I mean it because I in my experience, I was working with many programming languages, Pascal, PHP, C++, Python. I mean, yeah, many, even niche ones like Smalltalk, Prolog. And the reason why I stayed and I kind of I have been working with Go, I don't know, maybe 7-8 years, and I still love it. I mean, there are many reasons already stated in Go times, so let's not repeat that. But the point I want to make is that it's very powerful to keep this Go language as a foundation to create more specialized tooling, right? And you can have a lot of benefits by just keeping, this foundation to inherit simplicity, reliability patterns, tooling, like for example, IDE integrations, documentation building, auto-completion. Like some of it is that, for example, like JSON language for configuration. Maybe it's good, but I don't have hints when I kind of point my fields of this JSON. Nothing kind of hints me what the structure actually implements, and Golang already have that, right? So why not reusing this and building on the shoulders of giant? And I really mean that. And we have like we use configuration in my past job to build kind of configuration for infrastructure in Go, and it wasn't perfect because there are some features of the language that maybe are too much. You have for loops, you have error checking, and you have a little bit of boilerplate. But if you refine the language, maybe specialize a little bit, then it might just fit the use case just very well. Why we are creating a totally new languages from scratch, like Q or JSONet, if Go is so almost perfect, if a little bit is needed to perfection. And maybe last example, embedded systems I mentioned. Of course, garbage collection is not very efficient here, but there are already implementations of manual allocations. I think dgraph created like a special allocator, and there's even VLang, which also kind of removed GC but kept some of the features that Golang did. So we might have maybe a version of Go that has Rust-like memory ownership. And that would be amazing because we keep other features instead of kind of living with totally different decisions that Rust community made for other stuff that maybe I'm happy with. Right? So that's my unpopular opinion here.
Wow, I'll genuinely be interested to see if that is unpopular with our audience, because maybe a lot of people would agree with you. I don't know.
The Go fans should all agree, right? But I disagree. For one, I think it's a truly unpopular opinion because I disagree with it.
Great.
Fair enough. Okay. Well, I'm afraid, that's all the time we have for today. But this has really flown, and that's how we've had a good conversation. So thank you so much for that. We heard all about monitoring there and observability. The myth of Prometheus, very interesting, the origins there of that story, and as well as exploring the exemplars and the good kind of practices and things. So I think it was honestly, genuinely very helpful. Thank you so much to Bartek Plotker. Bartek, will you come back sometime on Go Time?
I would love to, yeah.
I'd love to have you. Björn Rabenstein also, will you come back?
Yes, sure. It's one of my favorite podcasts, and if I'm in there myself, even better.
Is it?
It's boring for me then, but it's a great honor.
Yeah, if you remember everything you've said, that's boring. So if you can, try and forget it, or just listen to it in a couple of years. But yeah, no, if you could just say that you'll be back, that'd be great.
Yeah, I'll be back.
Thank you.
No, I should say it with the Terminator voice. Yeah, I'll be back.
Yeah, that's just your normal voice, isn't it, Björn?
Sometimes, yeah.
And of course, Johnny Boursiquot. Thanks, Johnny. It's always good hanging out. Björn, good luck with finding John Connor. We'll see you next time on Go Time. I'll try and play the outro music, but I wouldn't hold your breath. No.
Yeah,
No, that's
music
it, yeah.
fail. This is
Music
where
fail.
we cut it later.
Yeah,
The
we'll
live
put it in.
listeners don't get the music.
No, but you get all the extra bits like this. This is free, extra. You don't have to listen to any advertising. If you watch it live, you can skip the advertising. That's basically like the equivalent of it being free. When the podcast goes out, you've got the lovely edit, you've got the polish, all the space and awkward silences are cut neatly, but you got to listen to the ads, and in a way that's
Oh,
the
you
trade-off.
support changelog and you don't get the ads, right?
That's true. Yeah, there's a changelog plus, isn't there? I don't benefit at all from changelog plus. I'm just saying, it's quite a cool name for it, though. To be fair, isn't it? Okay, well, this was great. Thank you so much. We'll say goodbye now to all our live